Hey everyone, welcome back. In this video, I wanted to review the sample syllabus from the College Board that is provided for AP Calculus AB so you can have an idea of what to expect this coming year. So if you scroll down, you can see here they provide a rough course outline and pacing. Of course, this is going to depend on your teacher, exactly, of course, when you're going to learn each unit. But roughly, to give you a high-level idea, usually semester one is focused on the concept of the derivative, which we'll talk about a little more later. And then second semester is focused more on the concept of the integral and, of course, reviewing for the actual AP exam. So now let's go through each unit. So unit one focuses on limits and continuity, and this is really where you bridge your pre-calculus knowledge to your calculus knowledge. So depending on the curriculum of your pre-calculus course, you may have already been introduced to the idea of the limit, but in this section, you're also going to tie it to concepts such as horizontal and vertical asymptotes, which you learn when you talk about rational functions. So all of these functions that you learned are now going to be really important and really the building blocks for your calculus course. So in this unit, you can see we're going to talk about can change occur at an instant, right? So here we're talking about slope. So we're introducing the idea of instantaneous slope versus average slope, or instantaneous rate of change versus average rate of change. Of course, you're going to go over limits and limit notations. You're also going to learn how to estimate the limit three different ways: from graphs, from tables, and then also algebraically. This is where your Algebra 2 skills are going to come in a lot. So it's really important you're really comfortable with factoring, for example. You need to be really sharp on that. Let's see. Okay, great. Yep. So that, and then you're going to be introduced to the squeeze theorem, which is really important. And you're going to talk about different types of discontinuities. So jump discontinuities, infinite discontinuities, and then removable discontinuities. Okay, moving on. Here we go. Yep, you will also talk about continuity and how it relates to discontinuity. So for this part, it's really important to have a solid foundation in those parent functions that I've kind of been talking about. So for example, your rational functions, your polynomial functions, your quadratic functions, you should be comfortable talking about all of those, knowing what they are, and then knowing a lot of the tools that are required, which a lot of it is factoring, but there are other ones as well, and knowing how to use those and apply them to those functions. Here we talk about vertical and asymptotes and how they relate to limits. We go over the intermediate value theorem, and then we move on to unit 2, which has to do with differentiation. So this is where you actually learn the idea of the derivative. So in unit 1, you are really still working with the derivative, but you're using the formal definition of the limit. In unit 2, you learn all of these shortcuts to take the derivative in a much quicker way. So a lot of my students wonder why we even did limits at all, because once you learn the easier way, you just feel like it's so much easier. But anyways, okay, so 2.1, defining average and instantaneous rates of change. Average rate of change is literally just your Algebra 1 slope formula, y2 minus y1 over x2 minus x1. Instantaneous rate of change is where you take the derivative and find the slope at that specific point. 2.2 has to do with notation. 2.4, we're talking about connecting differentiability and continuity. So you learn if a function is differentiable, does it mean that it's continuous, and vice versa. 2.5, you learn the power rule, which is going to make your life so much easier. It teaches you how to take the derivative of functions like these. So y equals x squared, y equals x to the third. Then you learn more rules, so constant sum and difference formulas. Then you learn special derivative formulas that you'll have to memorize in the beginning, and then they'll become just second nature. So cosine of x, sine of x, e to the x, natural log of x. Then you learn product rule, quotient rule, and then you learn more advanced derivatives of tangent, cotangent, secant, cosecant. All right, and then unit 3, now you learn different, really, techniques to take the derivative of more complex functions. So we start with the chain rule, which is applied to composite functions. So again, you should be comfortable with that word composite function. If not, I would recommend reviewing what that is. You learn how to implicitly differentiate a function, which is where you basically have x and y on the same side rather than the function already having been solved for y. You learn how to differentiate inverse functions, how to differentiate inverse trig functions. Let's see what else. Higher order derivatives. So you also learn how to take the second derivative. So up until this time, you've only taken the first derivative, but to take the second derivative, you take the derivative of the derivative. All right, and then unit 4, this is where you get into applying all of those concepts and rules that you've learned. So this is where we typically introduce position, velocity, and acceleration graphs and learn about things such as average velocity, average acceleration, and also how to read those graphs. Related rates as well. So this is where you will, it's really no different than what you've been doing. It's just applying it to formulas, let's say such as area. So let's say you have area equals pi r squared, right? So now you're not necessarily just dealing with quote unquote typical functions of like y equals x cubed. Now you're dealing with the area function or a volume function or something like that. You also are usually introduced to linearization at this point, which is a really useful strategy for estimation. Basically, you plot the tangent line, or you not necessarily plot it, you could also just find its equation, and then you use it to estimate the function value at that point. So it's really commonly used, you can see here, to estimate square root values. Finally, you learn L'Hopital's rule, which teaches you how to determine limits of indeterminate form. So this is kind of tying back the concept of limits to unit 1, but you're learning a more advanced technique for evaluating limits that you previously did not know how to evaluate. And then finally, unit 5, this is where we introduce new ideas such as the MVT, mean value theorem, extreme value theorem. We learn about extrema, and if you think of the word extreme, right, it's the maximum or minimum point. You also learn critical points, okay, and then you also learn where the function is increasing or decreasing. So all of this is really teaching you ways of really how to graph a function if you didn't have your graphing calculator. So you could find all of these things and put all of the pieces of the puzzle together to get a really good idea of what your function looked like without actually using technology to assist you. Okay, and extrema are important, of course, in the real world, right? Let's say you work for a business and they want to maximize their profit or they want to minimize their cost, right? So again, you're putting all of these things together to learn how to use the derivative to analyze the slope and figure out why you care, right? And how to find the highest point or the lowest point. Okay, and then you also learn how to use the second derivative to look at concavity. I like to think of concavity as kind of like a bowl. So is it concave up or is it concave down? Meaning, is your bowl sitting on the counter facing up, or have you flipped it upside down? Okay, and then again, what I was kind of talking about in 5.8, sketching graphs of functions and their derivatives. So again, you're putting all of this together and you're learning how to create a graph of a function. You're also going to learn about optimization, which is something I was kind of already talking about. Again, let's say you have this is a good example actually that they give here. So let's say they want to optimize volume. They want to find the maximum volume, right? So you learn how to find, you basically just learn how to find the greatest volume by using the techniques you've learned up to this point and applying them. All right, that is all for now. That's kind of a typical semester 1 overview. So I'm going to stop the video here and then we'll come back and we'll do a semester 2 overview.